of the nitric acid, so we'll add the 2 mils of nitric acid. There's 1. There's 2. All right, so the next one, number 2, needs 1.5. So there's 1. Now I'm going to go to a 1/2 ml volume. And there's a 1/2. Number 3 needs a 1 ml volume. So we'll dial it back into 1 ml. Number 4 needs only a 1/2 ml volume. And then number 5 doesn't need any. And kind of a check to see that if I've done these right, they all should have the same total volume in them. So they all should have a total of 5 mils. So I'm just going to back up and look across the line, and they all look about the same height. Now if you'll look at these and look at the numbers, you'll see that the color intensity changes on these. What happens, the one that's the darkest color, it's produced more of the iron complex. So there's more of the product made in number 5 than there is in number 1. Okay, so that kind of gives me an idea that the system's working like it should. I'm going to check my camera right quick, make sure it's still recording. And it is. So now we're going to go over to the instrument and we're going to try to record some data. So I'm going to take these to the other side with the instrument, and this is our Spectronic 20, and then we have a newer version of it. So the lab says that we're going to use this guy. This is the Spectronic 20, and then I'm also going to show you a newer one. So I've got one more sample to pick up. So let me get this this standard. All right, so first thing I want to demonstrate is the wavelength that we're going to choose to use. So the instrument, the Spectronic 20, chooses a particular wavelength, and you can dial in the wavelength that you want by adjusting the knob that's on the top here. And the report, or the lab write-up, says to use wavelength 447. But why are we choosing that wavelength? So this instrument can only look at one wavelength at a time. This is a more modern version of this instrument, and this one is actually a scanning instrument, so it's capable of doing a spectra. So they use slightly different cuvettes. The cuvettes that the Spectronic 20 uses is it uses this round cuvette. Looks just like a test tube, but it's got, the glass is a little bit more refined in its uniform thickness. And these use a square cuvette. Now these are plastic ones, so they're disposable. First thing I'm going to do is I'm going to get a scan of water. So I'm going to put water in, and I'm going to go into scan mode, and I'm going to tell it to scan. And it's going to do a spectra for me and make a measurement for water. So I'm going to hit enter, and it's going to say scanning. And I'm trying to make sure my camera is kind of pointed in the right direction. And what we see is that there is a baseline here for water. So I'm going to see if I can look at the measurement associated with that. So there's it's pretty flat across here where this is, but it looks like the absorbance that's showing it at different points from 400 to 900 nanometers. It's pretty flat. There's not a major peak in here. And if I can remember how to zoom this out, so let me go to the enter, and I'm going to hit the 0 button. and scan and enter. I'm gonna hit 0, let it auto 0 with just the water in it. Forgot to 0 it first. And now I'm going to go to the enter to scan. What I should see is that the value for just the water should be right at 0. And we can barely see some little red dots in here. So it's right at 0 from 400 all the way up to 900 nanometers. Now I'm going to switch to a solution of this complex that I made up. So this is the standard solution I made up. And I'm going to put a sample of that in the instrument, and I'm going to go through and get a spectra of it. So I'm going to scan it, and what we're going to see with it is that there's going to be a peak or an absorption down here around 400 nanometers. So here's that peak that I talked about. So if I dial to find out where that peak is, I'm going to take my green little cursor, and I'm going to find out where the center of that peak is. All right, now our lab write-up says that it should be done at 447, and I don't think that's the number we're going to use, so we're going to adjust it to this number. The instrument shows that that peak is the largest at 462, so we're going to modify our experiment and we're going to make the measurement at 462. Okay, so that looks like it's ready to go at 462. So now I'm going to come back to this instrument, and this is the Spectronic 20D. So the sample goes in the instrument in these little tubes. So this is called a cuvette. I'm gonna rinse it with some water. I'm gonna put a little more water in here. You wanna try to fill them about half full of sample, and then always wipe the outside of it off before you use it. So I'm gonna get it ready to go. And we said the wavelength we're gonna use is 462, so I'm going to dial it up to 462. And then with nothing in the instrument, you take the left knob and you adjust the 0% T. So I want to take the left knob and I want to turn it up to where it reads right at 0, or as close as I can get it to 0. And if it's off by 0.1, that's fine. We don't have to worry about that. But if we can get it to 0, that's where we want to be. So that's right at 0. Now this one's actually got a switch on the front of it, and it's a filter switch. So if you're using wavelengths below 600 nanometers, you leave this switch to the left. It's above 600, you flip the switch over to the right. Ours is below 600, so we need it to the left. Now to calibrate it, what I do is I put a blank in that's just got water in it. So there's usually a little mark in the front of these. You can see there's a little dimple in the plastic here. To make sure that you put the cuvette in the same way every time, I'm lining that B up on the front. So now with water in it, I'm going to take the knob that's on the right hand side that says 100% T on the front of it, and I want to dial it in till where it reads the value of 100. Now this one's a little bit more finicky to get to the perfect 100. But maybe we can get it there. A little too far.